cellular respiration formula, actually if you put fuel in, is the formula for common combustion. And one of the things that we talk about a lot is, you guys all said, 7th graders, how many of you guys have been camping and you have a campfire and you blow on it and you notice the campfire gets bigger? Well, what you're doing, you guys, is you're adding oxygen, and that will consume the fuel faster. People say, well, gee, Mr. McKinney, I exhale CO2. How does that make the fire burn better? Well, actually, when you blow, you guys, you're pushing the air between your face and the fire into it, and it adds O2, and you know what that does to a fire. And I'll do it to you backwards, you guys. These lighters that you were playing with that you noticed are very similar to a candle, wouldn't you agree, the flame? It's yellow, blue at the bottom where the oxygen's entering the chemical reaction, and then you have your yellow soot, ash, waste product stuff coming out the top. The torch I have here is exactly the same fuel, you guys, but you'll notice I'll do this all day. A lot of you guys were jumping right through. Yeah, no. Probably not, right? And just by looking at it, you guys, it looks a lot more like your stove at home, and it's about twice the temperature of the flame. Michael, thank you. I'm trying to conserve fuel while you're staring at that. If you listen, you can hear something. You hear the whistling? You won't hear that with the lighter. And what the difference is, you guys, is the torch is designed with these little air ports, and the fuel is mixed with air down here. And so as it enters, it oxidizes, and it's actually the exact same material, but because it has more oxygen, it's just like your campfire. It's burning at a much higher temperature. But watch this, you guys. I will turn my torch into a candle, and then Jace or Jake come up, put their hands right through it. Listen to the air as I brought the ports. Half, 3/4. Come up, put your hands through it.
I'll do it.
Proving that I can turn a torch to a candle.
He's gonna let go right as he does.
Yeah, right as he does it, he lets the things off.
That would be hilarious.
No problem there. And once again, I have a rather cool 600-degree flame rather than this reintroduce the air. So part of learning about fire is why things work, and oxygen is just as important as the kind of fuel you're burning. We can also get different temperatures by messing around with different kinds of fuel. The other one, you guys, that's really important is this business of making water. If you were looking very carefully, you might have seen it on the inside of the beaker, but if you're consuming fuel faster, it would make sense that you're making water a lot faster in CO2. And so what I'm going to do is just gather the waste gases coming off of this up here, and you'll see occasionally a little flash of yellow in there. But watch quickly, if you keep your eyes on here, watch how fast, you guys, it'll form a cloud when it condenses on the cooler glass. The flame is pushing out the water, and it's in vapor form, so you can't see it. And how many people see it condensing on the glass as it cools? And so I can make a rather nice cloud, and if I leave it here for just a minute, you guys, it's quite remarkable how much water there is. It's very, very wet. And this would equate to, how many of you guys notice that when mommy drives her car on a cold morning, it steams out of the exhaust pipe? You guys, that's the water and the fuel that's coming out of the exhaust pipe. Normally, it just stays as a vapor when it's warm, but if it's very cold out, my 8th graders know the air shrinks it, it condenses and forms, turns back to a liquid and makes a cloud. Same thing you see on airplanes, you guys, up about 35,000 feet. Those white things behind them, that's not exhaust, you guys, it's water. It's ice crystals coming out of the fuel as it's burned. It's really kind of cool contrast. All of those are the same. But let's see, what else do we have? We'll do breathing beaker because I like this class. This is my new one. This is just a crowd pleaser. How many of you guys were impressed with the smoking wick trick? That's always a crowd pleaser. This idea, and if you start now looking at logs or something like that, you'll see that if you watch a campfire, you'll see little gas jets coming out. Everything must turn to a gas. And I was dinking around with this one earlier this year. It's still in development. It's a little radical. And you guys are far enough apart. Has a tendency of spewing liquid alcohol out, but I have the same junk that was burning on your table, but this time, you guys, I've trapped it into a flask and attached a tube to it. And what I'm going to do is boil the alcohol. And when you boil something, I think you guys realize that's where it's turning from a liquid into a gas. And so as soon as it starts to boil, it's going to pressurize alcohol gas, and it's going to drive it out the tube. And I'll make a rather cool little torch. Right now, you can see without the heating, there's no alcohol coming out. Let me boil this and see if I can do it without cooking my hand. Had a few research and development problems with this one. First couple times I tried it, it spews out liquid alcohol. Got on some kids, might have a problem.
I'm okay now.
Didn't get any phone calls.
I'm okay now.
Did everybody see it's boiling now? That's very dangerous to do, you guys. You really don't want to boil alcohol, but now I can light my rather cool little flame, you see, and it's driven out the top. And let me get it rolling here. Gets to an equilibrium point. It's actually boiling too hard now, where it just about is perfect. Has to heat up, Alan, that's what I figured out.
Yeah.
And if it's boiling too hard, it won't stay lit. It keeps blowing itself out.
Glass keeps it
Yeah.
You can see the little spews.
You can see the little spewy parts of alcohol there. The alcohol condenses on the inside of the tube and then spews out these little burning things which land on people. You probably don't want to burn the seal. Isn't that kind of cool, you guys? Watch this. If I take it off the heat, within a matter of seconds, stops boiling. As soon as it stops boiling, watch the flame drop.
It's like automatically.
So, yeah, and now I can't light it, you guys. There won't be any left because there's no. So that's just another proof of the vaporization. Everything must become a gas before it can burn. One more trick?
Yeah. As many as you have.
50 more
tricks. Go, start tricks.
Almost out of fuel here. You guys, 7th graders, I want you to speculate a little bit. Remember the picture on the whiteboard of convection in the candle? And how the blue part is where the air is entering the chemical reaction and the yellow is where the exhaust. It's kind of like the front end of a car and the back end of a car. Or, as we said, sort of like your mouth and the other parts. The exhaust is going out the other end. And in a candle, you guys, it kind of flows right through. But I've dumped some methanol in here now. It's in the beaker. But talk to the other 7th graders, and what's the problem with this? How is it different from the candle when I go to light the methanol? If you remember on the table, I got that beautiful blue flow, right? So how is this going to be different? What's the problem with it? Go to work.
Well, okay. Commence.
Not 8th graders, 7th graders. 7th graders.
Commence your words.
Word.
Commence wordation.
Word. Because.
I do occasionally.
How you doing, yeah?
How you doing? Hey, Michael. Is we be balling?
Fan?
Oh, yeah. Where's the ball? I'll be a cheater. Alright, guys. Sam in the beaker. Take a ball.
Nick, do you?
No, I actually don't.
Alright, guys. Let's just assume that the ball burns to death.
Okay.
There's any chance that there's fiber out there, I'm gonna find him. Do not give up. Bring him home.
What did you do with
What have you done with my ball?
Let's think about. Okay.
Let's think about your breathing. Can you breathe in and out at the
The
same
oxygen
time?
comes in through here. What if we cut off the bottom? Like in the beaker. How is it going to get any oxygen?
It's hot ball. We're supposed to bounce it back.
Guys, how is it going to get any oxygen if we cut it off the bottom? How, Brandon? How? Lives are depending on this.
I don't know.
You suffocate.
You should get Albert Einstein in. He could fix this.
No, he couldn't. He's too dead.
Don't tell me that.
7th graders.
It's not true.
What's the problem? Yes, sir. Thank you.
O2 is only coming from the top instead of all around.
Yeah, we're going to have a real problem having this convection thing going, right? Because the thermal energy made by the fire is going to drive the waste products up. And if the oxygen tries to get in, what's coming out? The CO2 and all that, right? So it would be, if you're with me, it would sort of be like trying to exhale and inhale at the same time. You can try it, but it doesn't work, trust me. It's the same as drinking water standing on your head. It just comes out your nose. Okay?
That's a
so,
lie.
the cool thing about this, you guys, is that it leads us to the role of convection. What's going to have to happen is that, thank you guys, thank you Tim. The oxygen will have to enter through the top. And when it comes into the beaker, it will turn it blue, right, just like it did with the candle. And you'll see the flame turn completely blue, and then it will get very large, turn yellow. That will block the oxygen from coming in, and the flame will almost go out. And then that will allow the oxygen to re-enter, and it will flare up. So in other words, you guys, the beaker will pulse. And when you see blue, that's an inhale, and when you see yellow, that's an exhale. Oh, I need my lighter over there. You can pass me my blue wand. Lest I don't fry myself completely. Didn't wear my long sleeves today. We'll try this. I need a haircut. If you blow out the fumes, it usually doesn't fry you too badly. There we go. Blue is in, yellow is out. You can even hear it breathing if you're quiet. Hear the air rush in. I call this the breathing beaker. Is fire alive? Isn't that cool? Yes, it was alive. Very good. Who said that? Very good. Thank you. Where's the piece of paper? Then you can see, guys, when it goes for an inhale, put a piece of paper over, it'll actually pull the paper down as it tries to breathe. Get pulled down on the paper, but then it's sort of like suffocating. As you know, we took away one of the members of the triangle. Dr. Savage, thank you for having us down. 7th graders, you guys were, this was the best audience I've seen yet. This was a great group.